Hello everyone, and thank you for joining us. We have today Dippy Yaman Basu, who will be taking us through ABB Emax to air circuit breakers. Before I hand over to Dippy, I'm just going to go through a few housekeeping points with anybody who is new to our webinar. If in front of your screen you will see Dippy's presentation. To the left and to the right you will have your control panel where you can check your audio and type in your questions. Throughout the presentation, everyone will be muted by design. Please feel free to type in questions throughout the webinar. They will be answered at the end. Any questions that we do not get through today will be answered offline. This webinar will also be recorded, and you should receive a copy of it in an email or a link to it in the email within 24 hours. And lastly, I'd like to remind everybody that there is a short survey after the webinar, which we'd like you to stay online and answer a few questions and give us your valuable feedback. And with that, I'm going to hand over to Dippy, and I'll be back with you for question time. Dippy, over to you.
Thank you, Isabel. Good afternoon, everyone. Like Isabel already has said, we're looking at the Emax 2 air circuit breakers today. My name is Dipyaman Basu, DP for short. I'm the product marketing manager for breakers and enclosures for Australia and New Zealand, mainly a part of the electrification smart power business. Now, before I begin, I hope everyone is safe, and our intention is to try and help you as much as we can during this phase of time that we have of extraordinary circumstances, and we are committed to try and support through your businesses while we do ours as well. Now, coming back to the topic of discussion, Emax 2 air circuit breakers. So the Emax 2 range is mainly focused on AC applications. We also have certain, and this is mainly up to 690 volts and some range also going up to 900 volt AC, which is specific to solar applications and few others, which require higher level of voltage. We also have separately 1000 volt or 1150 volt application circuit breakers. They are of a different family, which means that the electronics are not shared with Emax 2. However, the features and performances are not that far off. Then we also have a DC version of the circuit breaker, which is one of our quite proprietary products. What we speak about today is just Emax 2. So before I get into details and start talking about the exact features and the range and those kind of things, I would like to share with all of you the first thing, which is the concept, or what was the thought behind development of Emax 2 as a product from our research and development all the way through our product marketing, global product marketing teams. Now, the three main things in focus, mainly for customers and partners, and to an extent even ourselves. So what the product was focused on mainly on was design and planning, was initiated to make sure that we can reduce design time and cost of the system and not over design a particular setup when we are looking at the planning or design stage. Now, I'll go into more detail as we go along, but I'm just trying to give you an overview. And then there's the next phase when things are on order, or some things that we're putting together in terms of installation or startup and commissioning. We want to minimize the man hours in assembly or any kind of labor component in putting together the particular product in a system. Emax 2 by itself doesn't go alone, so it is always a part of a system. It also works in parallel to other products in that particular system, whether that's motor protection, power distribution, or any other kind of setup such as solar or renewables and such. In terms of operation and service, reliability is extremely important. Safety of people while operating on the breaker is our top priority in ABB. So we keep those things quite easy and quite straightforward without complicating things which could be harmful or dangerous in terms of operation. When it comes to the product itself, now an installation once has a particular product installed, we would expect at least a lifetime of 15 to 20 years, sometimes more. During that whole period, the product doesn't change. It's the same product functioning mechanically and electronically, providing input and output throughout the system. Now, with Emax 2, the intention has been to make the whole system future-proof, which means that there is possibility of upgradability while we go down the lifetime of the system. I'll go a bit more in detail. So what we're going to discuss, or what I'm going to talk about today, is how Emax 2 helps a particular setup or particular power distribution setup. One, there's the performance. So not only do we look at high performance in terms of the breaker being able to perform, but we also look at the size and the footprint of the product itself, the features of different accessories that we would have installed within the breaker without changing much within the system. It fits with Emax 2 quite well. In terms of control, we're talking about trying to optimize power flow. So whether it's in a certain setup, whether it's interfacing with a microgrid, or we talk about a standard distribution, power distribution, or motor control, there are possibilities to be able to control different setups right through the breaker without separate accessories, relays, or control logic, let's say. Connectivity uses universal protocols of connection and communication. Plug-and-play devices are used to connect onto the breaker, not just to behave as a power distribution circuit breaker, but also behave as a brain for, let's say, a switchboard, a low voltage switchboard. And then there's the ease of use. So how easy it would be to use the breaker to ensure that we are able to extract all kinds of historicals or current measurements, or if there is a trip or fault or alarm, then to understand what's really happening in the system. The breaker allows us to do that quite clearly and easily. So with protection, we have a lot of advanced functions. We have advanced functions focused at microgrids, also at distribution systems. Measurement, we now come to a class 1 measurement, which means that we have upgraded from the class 2 as our previous generation of Emax 2 to the newer trip units, which will be covered during this webinar. And there are certain logics which allow the Emax 2 to control downstream devices. And we'll be discussing that as well. And to end it all, of course, we have connectivity. So there's always a peripheral management system on top, whether, depending on the kind of installation we have, of course, we have DCS systems, PLC, or even some sort of monitoring or IMCS systems on top, which the Emax 2 allows to connect to quite with ease, given that we are able to use almost all the protocols we have largely used in the industrial space. Now, speaking of performance, we look at Emax 2 in mainly 4 construction sizes. So we have the E1.2, the 2.2, 4.2, and 6.2, right from a 1600 amp, which can be brought down to 250 amps, all the way up to 6300 amps. We have high short circuit ratings even in the smaller sizes. And then at the end of the day, they're optimized to carry higher current with a lower footprint. That is also in correlation with other conducting material within a switchboard, and then looking at temperaturized calculations separately. But the device itself allows us to reach certain footprint reductions. In terms of embedded functionalities, we have a lot of options, which I'll be discussing quite soon. Now, what do we achieve from this? Like I said, so we reduce footprint. Our predictability is almost 30% and can change based on the application and the other parameters that we have linked to that particular setup. There would be reduced busbar length. If your switchboard is going to be narrower, then we would definitely have some saving in terms of copper. And then there's sheet metal, which might not be significant, but it's saving at the end of the day. So what are we talking about? We're talking about 4 construction sizes. So the E1.2, which is up to 1600 amps, can be fit onto a 400 mil wide tier. The E2.2 goes up to can be either a 400 or can go up to 600. Now the 400 would be limited to a 3-pole circuit breaker, and the E4.2 goes from 600 to 800, and then the largest one needs at least 1000 mil wide switchboard to fit into. So this is how it's designed to try and not only look at the product and functionality, but also where it fits as a part of the system to make it easy for the system to be easily designed and, let's say, flexible enough to fit into any sort of situation in a switch room while complying to installation and service rules that we have in the country. Now, in terms of the particular breakers, the breakers are from 250 amps all the way to 6,300. Of course, they are in accordance to 60947-2. We also have certain high voltage Emax 2s, like I mentioned a bit earlier, which allows us to go all the way up to 900 volt AC. They are special breakers with the same technology of the current Emax. The current Emax is generally rated up to 690 volts, obviously with similar current ratings, but different short circuit and KA ratings and ICW ratings. The commonality between all the breakers is that the terminal boxes and the connections and the auxiliaries are all the same throughout the whole range. The height and the depth of the breaker has not changed. The only thing which changes is the width. Obviously, with the size of the poles, you have larger width in terms of the size of the breaker. As we go higher on the current ratings, the size goes up. As you saw previously, the panel sizes go up with the larger breakers we have to accommodate larger current ratings. Then we have we will speak about the first 2 breakers we look at from the range. One is the E1.2, which is the most compact range, and the E1.2, and we also have a molded case circuit breaker we call the XT7. Previously, that we had a breaker called T7. They're pretty much exactly the same size. The difference is that one is a molded case and one is an air circuit breaker. The protection levels are quite significant in this range as well. We can look at not only 1250 amps, 1600 amps, we look at 66 kA when it comes to that particular breaker. Then the E2.2, which is our 2500 amp breaker, we can go all the way up to 100 kA and can fit onto a 400 mil wide switchboard. Now, having said that, that's quite a compact design. Now, there are certain other parameters that need to be looked at when we are trying to fit a large breaker in that, and that will be based on temperaturized calculations as we do as standard. And looking at the next ones, we have E4.2, which is our 3200 and 4000 amp circuit breaker. Now, based on the KA ratings, if you're looking at a 2500 or 2500 amp breaker at really high KA levels, we generally step up to the 4.2, which does not change a lot in terms of dimensioning, because E4.2 at that range is also quite a good design in terms of dimensions. It does not use multiple poles per phase. It uses still a single pole, but obviously the mechanism and the contacts and terminals are larger in terms of copper. And then we have the biggest one we call the E6.2, goes up all the way to 6300 amp. It's a double pole structure. So whenever we have a particular breaker in a certain current, we look at open and closing 2 poles simultaneously. Obviously, all poles close simultaneously, but it's two poles per phase, which gives it the size and the current carrying capabilities with short circuit performances. That's on the performance. Now, I would like to talk a bit about also the measurement capability. So like I said, we have gone up on the accuracy class. So as per 61557, we look at accuracy of 0.5 and 0.5 for voltage, and power is 1. So that's what we call class 1. We can look at a lot of different measurements, whether it's current, voltage, frequency, power factors, peak factors, harmonics, kilowatt hours, all that is possible through the Emax 2 range. And then the data is available instantaneously, which means that we have quite a high sampling rate of trying to extract any kind of diagnostics or historicals we want to extract from the system, not just to understand how the breaker is functioning, but also be trying to, let's say, analyze data which comes out of the breaker. Now, this in terms of performance, the energy analysis and the data analysis becomes quite important. It's quite straightforward system to extract the data regardless of the application, whether we're looking at a commercial application, renewable, microgrid, or battery storage, or maybe some other kind of installation. The energy is easily brought to a user identification level, and we have various ways of mapping that data, and I'll get into that, without use of external devices. So we have the class 1 energy and power, and then analysis of energy demand, which becomes important for a owner of a certain plant, a facility manager, or someone who's looking at power consumption on a quite regular basis to optimize control and optimize, let's say, production and efficiency of the whole system. Now, speaking about control, Emax 2 is embedded with a lot of technology, which allows us to use different applications in different different setups, let's say. So if you're looking at adapting onto certain conditions, that's possible. We look at managing different energy sources, whether it's multiple transformers or generators or whatever the energy source may be. Interaction with microgrids or in interaction with main grids, sorry. How that works, how the interface system works, how the breaker automizes or makes it simple to interact with the main grid. And then we have power consumption. So if you're looking at being efficient of power supply or power consumption in a certain setup, it's quite easy to do that. Now I'll describe each of these a bit more in detail to understand what is the actual functionality and how that works. And then there's minimizing downtime. So we don't want a critical plant to go down if there is any requirement of maximum power level. So things like load shedding come into play in that certain aspect of things. Now, looking at them a bit more in detail. So adaptive protections, that's one of the software functionality we have with Emax 2. Now, this is available only from the eKeep Touch version. That's the trip unit type we trade in Australia and New Zealand. That's the main one, and we have a higher range, which we call the high touch. So what the adaptive protection allows us to do is it allows us to guarantee selectivity. Now, switching between two setups where you have a main grid and a microgrid kind of setup, the protection levels or the power levels can be different. So you'd probably require two different sets of protection on each kinds of source of supply. That's quite easy with adaptive protection, which is what we, in general terms or practical terms, we call dual settings, allowing us to do two sets of settings in a certain setup within the Emax 2 breaker to accommodate different sources at different times. Now, the dual settings are also helpful when we are looking at arc fault reduction. So if giving you a scenario, if you're looking at a maintenance setup where the protection is set at high fault levels, but if there's a physical intervention of service personnel on site, we would like the breaker to trip a lot earlier than a large current, so you can set them all the way down, quite easily actuated through a switch or some kind of a push button setup in a remote location. By pressing a button, it actuates a different set of protections on the breaker, so everything switches down to a level which is a lot more manageable. Now, this is not a protection feature. It's more to reduce any kind of effect. It's not an elimination, but it's a reduction of any kind of fault that we could have on site. But it's an option with the breaker itself. So combination of something as a reduction and protection together makes the whole system safe. So that's adaptive protections. When we talk about managing different energy sources, this is quite quite common in most setups. We have ATS systems. When the main goes off, we have a generator supply. Sometimes in different setups, we have two transformers ready to supply onto the same power distribution system. So what we call is automatic transfer switching, which is an embedded function in Emax 2. Now what that means is Emax 2, without an external relay or without having to install separate logics and electrical interlock through control relays and a quite cumbersome setup, it can be done right through Emax 2 within the electronics. So it's quite straightforward. All it does is we communicate between the two Emax 2s protecting the main source and the alternate source, and they communicate with each other through our eKIP link communication protocol. And we have something we call the synchro check module, which allows us to synchronize power supplies from the two sources and have a smooth transition. Now, in speaking of transition, we can look at either a closed transition setup and also an open transition setup. So that's possible with Emax 2. Then we have interface protections. Now, this is mainly on reclosing. So when we are looking at going back to the main grid to supply, the synchronizing relay, which I just spoke about on the ATS setup or embedded ATS, uses the logics to leverage, let's say, syncing both power supplies to ensure that we don't have any loss of time or downtime. That's a protection which can be a part of the Emax 2 setup as well. Power consumption, we're talking about something we call the power controller. So a power controller is an accessory, which is now a software accessory, which means the hardware remains the same and the breaker can be upgraded to have that functionality. Now, the power controller basically is what controls loads downstream. So the Emax 2 as a main breaker or main master behaves as the brain for the whole power distribution setup with, let's say, up to 15 devices downstream. Anytime a particular device is probably going through a larger current than required, let's say you'd like to cap the peak use of power from a particular device downstream, Emax 2 can recognize that and then automatically control that breaker through Emax 2 by itself with no external relay, but just the power controller enabled within the breaker. And this can be done up to 15 devices. And then there's the downtime. So we want to avoid any kind of blackouts. We want to avoid downtime for our end customers. When we have a limitation to power supply, this comes into play, the way we look at load shedding. So you can have a certain scenario set up within the logics of Emax 2 trip unit where you have priority and non-priority loads based on reduction of energy or power supply or restrictions on power supply. We can switch on to just the critical loads or priority loads, as we call it, and then have the non-priority, non-essential loads switched off. That can be worked out through a logic within the Emax 2 system or the trip unit. Now, speaking of the trip unit, we only look at three kinds. We have the eKIP dip, the eKIP touch, and the eKIP high touch. The eKIP dip is a straightforward trip unit, quite basic in nature in terms of its capability. And in terms of its advanced capability, it still allows us to have the complete range of protection. However, if you're looking at logic or embedded logics within the breaker or higher levels of certain protection, for example, if you're looking at having two kinds of ground fault on that certain breaker, would be a standard ground fault protecting the ground and a secondary ground fault, which let's say call it, let's talk about restricted earth fault. So if you want REF protection, that may not be possible in the dip, which allows us to have that functionality with the eKIP high touch and to an extent even with eKIP touch. So eKIP touch also comes with the embedded Bluetooth technology, is ready for measuring, which means that with a simple software upgrade, the breaker can have capability to have complete measuring, not just power voltage, current voltage, but it also goes beyond, and we talk about power factor, harmonics, and a lot more details which allow us to do network analysis. What we look at specifically within Australia and New Zealand is eKeep Touch. That's what we trade in this region, unless we need advanced capability, which is offered by the High Touch. Now, even with the eKeep Touch, we have the option or capability to go to the next level, be able to extend any kind of logics or functionality within that breaker, and can be all the way up to High Touch. This slide will probably give you an example of what that means. So the touch in standard comes with standard protection, standard measurements, but can be upgraded with the measuring package and all the other embedded logic packages that we have. eKeep G Touch comes with a measuring package and so on. So even an eKeep Touch installed in a plant, which is quite a competitive offering, and then down the line during operation, if the operator or the facility owner decides to have more functionality within the breaker, that's possible even with eKeep Touch, just through software upgrades. Now, speaking of connectivity, it's gateway free, so we don't have to look at any separate gateway. The space required is 0, because all it does is we use plug and play devices. Emax 2 is the first circuit breaker to integrate IEC 61850 communication without any external relays, which allows us to communicate not only with medium voltage but also higher to a DCS or micro SCADA or SCADA setup. We have a lot of different digital and analog interfaces, which can also work as communication to a higher level setup. And then the new trip units for Emax 2 come with embedded Bluetooth connectivity. Now, Bluetooth connectivity, I'll discuss a bit more in one of my slides coming soon. So what possibilities do we get? Remote connection. So through our standard industrial universal communications like Profibus, DeviceNet, Ethernet, or Modbus RTU, we can communicate with the device with Emax 2. At a local level, we have embedded Bluetooth technology. So without being able to open a panel door while the board is live, we can function a particular handheld mobile device or iPad to communicate with the breaker, to read the measurements, and also be able to change protection settings. Then we have our own ABB Ability EDCS, which is our electrical distribution control system. That is a monitoring setup up in the cloud with all the cybersecurity requirements fulfilled to allow a breaker to be communicated, to be seen from the cloud from any device anywhere in the world, as long as it's connected to the cloud. And that is enabled through also our plug and play devices we call the eKeep Com Hub. As you see, the plug and play devices are quite straightforward. They're like cartridges. All we need to do is ensure we have a power supply to them, which is within the Emax 2 breaker. And with that communication protocol, we are able to communicate remote, or also be able to look at ABB Ability EDCS. So protocols like RTU, TCP, Modbus, TCP, Profibus, IEC 61850 are part of the Emax 2 accessories portfolio. Now, Bluetooth connections, Bluetooth functionality, which is embedded in Emax. It's not necessary. It's not on always. It can be enabled based on user or operator functionality. Can be seen. The functionality of the breaker can be seen through Bluetooth through a Bluetooth device with software we call the eKeep Mobile, and that's quite easily downloaded and it's free of cost. What it allows us to do is be able to see what's really happening with the breaker in terms of measurements, what currents and voltages and what is really going through that particular circuit. And also, if required, we can function to modify or change certain protection settings based on requirement. And at the end of the day, once if we need to import or export any kind of settings based on a certain design. So if I give you an example, our proprietary, our software we call the curves, which give us the protection curves of circuit breakers, allows us to have a certain file which can be downloaded on your mobile device and be uploaded on the Emax 2. So it takes the settings right through from your design software which is computer based all the way to the breaker with ease, let's say. Then we have ABB Ability EDCS, which is our cloud-based energy and asset management system. We look at four main things on this. One is monitoring. So we look at monitoring a certain plant, device, assets. Optimizing. So if you're able to look at power, we can also analyze data. And all the algorithms to measure and analyze data is pre-ready on EDCS platform. So there is no requirement for extra programming. The Emax 2 device or devices which can go up on the cloud are quite easily put up on the cloud, probably in 10 to 15 minutes. And then we have the predict functionality, which allows us to predict well in advance if we may have a fault in that particular setup or environment. And then there's control. Control is more focused on trying to use the embedded logics like load shedding or power controller through the EDCS system. Now, this is quite high level of authentication. This can be done, but it's limited only to certain functionalities. Then we have ease of use. So the Emax 2 circuit breaker is made quite simple in terms of its architecture. The cartridge modules fit on the top of the breaker. The accessories accessories like shunt opening, shunt closing go on the right side. The motor operator goes on the left side. The trip units are interchangeable. So at any point of time, if there's a damaged screen or you'd like to have a higher level of trip unit, it's almost a plug and play device. 2 screws out, and then you can change the trip unit. Cartridges are interchangeable as well. So if their change in protocol can be easily changed. And then we have a large range of accessories within the circuit breaker, which allows us to have different functionality, which are hardwired functionality within the breaker. So we are talking about electronics, but we're also talking about mechanical accessories, which allow us to control the breaker as our standard applications go. Then in terms of commissioning, our eKeep Connect software is quite straightforward to use. We have that in place to not only be able to connect the Emax 2 to ABB Ability EDCS, but also program the breaker. So protection settings, being able to select logics with digital inputs and outputs. So if you're looking at certain digital inputs and outputs to be functioning and pulling out alarms to go onto a PLC or being able to give us some information, all that's possible, especially with the hardwired digital inputs, outputs. We have many options. We have literally hundreds of options to choose from, which can be dedicated to each digital input and output, allowing us to not only look at setting the device, but also certain level of diagnostic. The eKeep Connect software can also be used to test the breaker, which means if we are looking at a sort of secondary injection simulation, can be done through the eKeep Connect software with the use of a eKeep TMP module, which is basically USB to your computer, connects onto the breaker and then can be tested. We can generate reports on what's been the history of the breaker in terms of trip history, current, or what are the different things that have been happening in terms of its data. If it has a data logger function, we can also see a lot of network and analysis within the breaker, which is stored in the trip unit. And then testing, as I said. So the breaker trip unit can be made sure that it is functional and is tested as per it's supposed to function. Versions of the eKeep Connect, we have the EPIC Mobile, which uses Bluetooth to connect to the breaker, is more limited to the eKeep Connect on the laptop. However, there's the possibility of being able to communicate through your handheld device as well. Then when we talk about the life cycle and evolution of the breaker, this is where we said it's future-proof in the beginning. So the breaker can evolve. So the eKeep Touch trip unit, like you saw in one of my slides, is upgradable with all functionality all the way up to a high touch trip unit, which means the measurements, protection functions, or analysis on the network, logging data, all that can be upgraded through software. Now we have various versions of doing that software upgrade. It can be either specified from the factory side and be installed or enabled from factory. The other option could also be that we have something we call the ABB Ability Marketplace, which at this point is Europe-based. or US based, and we look at the one at Europe. So you can buy these packages online, gives you a username and an authentication code. With that code in eKeep Connect can allow us to upgrade the breaker with quite easily. And then the third option is a standard part number and pricing. So we have part numbers for these software upgrades as well. Although you don't receive a physical product, what you receive is a certain code which allows us to upgrade the breaker. So with that, a certain breaker at a certain point of the life cycle of the system requiring certain functionality, when we see evolution of requirement of functionality, this is where Emax 2 is future-proof. So a simple Emax 2 with a eKeep touch trip unit can be upgraded with any functionality that we look at. Now, that's what I have, and I'll be happy to answer any questions as we go along. Thank you for your time.
Thank you, Dippy. We have now coming to the answering of questions that were submitted during the presentation, but please feel free to continue typing in questions. We are short on time, but we will continue for a little while over time so we can answer some of those questions, and Dippy will answer anything that isn't answered online. He'll answer it offline afterwards. The first question, Dippy, is there an Emax, can two breakers transfer data or talk to each other through the Bluetooth?
No, that's not how that's not been done. And the reason is to ensure that we don't go into any complications of logics. So any kind of logic between two devices is always done through either is hardwired, or we have our own proprietary protocol we call eKeep Link, which allows to communicate between breakers.
Thank you. What security steps are involved with the Bluetooth app to stop undesirable controlling over the connected equipment?
So, like we have any Bluetooth device, we have a standard code. So to begin with, the first level of authentication is that the trip unit has a certain password to enable the user to enable Bluetooth. The next level is once the Bluetooth is enabled, so from your mobile device to connect onto the breaker, you need a common authentication code between both devices, which is shared, so that it can only be done to certain devices. And once you have enabled that device connects onto the breaker, but other devices cannot connect unless you put in, number one, the password of the trip unit, and the second would be the Bluetooth connection authentication. So it's two levels of security on that.
Thank you. The predictive technology, can that be a local server instead of the cloud?
Well, there are things that we are looking at in terms of development on that regard, but at this point, I don't have enough artillery to answer your question. But that's something which we can look at separately and discuss separately. At this point, I believe it's not yet there, but then we would probably have a solution. I would like to discuss that separately.
No problem. What are the predictive maintenance technology built in for an E4.2 version?
So the predict function of our ability EDCS, so number one is, as everything goes, anything in terms of maintenance or operations within the breaker, or the use and life cycle of the breaker, is dependent on particular application and particular environment. So a saltier environment causes more harm to the breaker, humidity being higher causes more harm. So these are the obvious things that we look at. So we have an embedded algorithm within EDCS. What the algorithm does is based on the environment, based on the operation, and also based on the breaker itself, which means we look at things like contact wear, we look at things like the number of trips the breakers had, at what levels the trips were done, and comes out with some kind of analysis where, or let's say more precise than we would imagine, that tells us on a scale of, let's say, a green being low probability of fault, to red being higher, it gives us a scale within the last 5 years the breaker has been installed within the plant. And that allows us to not only look at intervening and doing preventive maintenance from the prediction, it also allows us to plan our scheduled maintenance and things like that to ensure that the breaker is functioning to its maximum efficiency throughout the life cycle within that particular installation. Yep.
Thank you. Excellent. A question from a colleague: can the same software upgrade be used on multiple devices, one device at a time?
It would be one device at a time because it allows us to connect. However, I would believe that we can also look at Ethernet setup. So if it's done through eKIP TMP kit, that would be one-to-one. But through a common protocol like Ethernet or Modbus RTU, we can probably program multiple breakers, having them at different setups of different IP ratings. But does not mean that we can buy one package and have that throughout 20 breakers. We'll probably have to buy multiple packages, or we would have to buy a single package which allows 15 or 20 devices to have that particular upgrade.
Thank you. Question from one of our distributors: is there an Emax 2 presentation video available?
Yes, sure. So I think the webinar will be shared with you in any case. And further, I would get in touch with you in any case. So if you need anything further, any more information, we have a lot of data on Emax too, whether it's installation of accessories, how the functionality works. We have a lot of background of also technical information. So anything specific we can always address, and the generic ones will be shared with you anyway.
Thank you. One more from our distributor for you. If we purchase and install an E6.2, 50% neutral one, later, is it possible to make it 100% neutral? And if so, how?
Well, I think it's the other way around. So because this is the size of the pole, so if you look at a 50% neutral, the E6.2 uses 2 poles per phase. So you'd be looking at five pieces of poles. So sorry, 7 pieces. My bad. I'm having a daft day. My bad. So we have 2 per pole. So you have three poles and half neutral. That would be 7. But if you'd need 100%, you'd need 8. So you'd need to have the 100%. 100% can be set at 50%, but the 50% cannot be set at 100%. If that makes sense.
Thank you. Now, I know I'm conscious of time, and I do understand that some people will have to leave us, but there is a few more questions that I'd like to take. So those of you that have to leave, thank you for joining us, and I'll just keep going here with a few more questions, Dippy. What is the mode of connectivity, and can we use Modbus TCP in brackets IP and LAN for this?
Yes, depends on what we're trying to connect to. In any case, most of the communication protocols we have. So we have Modbus RTU, we have Modbus TCP IP. We also have Ethernet. We have Profibus, Profinet, DeviceNet, and 61850 IC 61850. So we have a lot of protocols which would cover a general requirement in 99.99% cases. What exactly is required with that connectivity would be the next question. But if you're looking at protections, changing protections, being able to control the breaker, all that is possible to communication. So how it works is we have the standard communication protocol, which sort of works in correlation with an actuator unit within the breaker, which works as a changeover contact basically. So if the comms instruct that particular actuator to go on to certain mode, it basically provides that information to the breaker physically, and then you can do a certain level of things. In terms of protection settings, that can also be done through the comms. There are certain ways where you can address certain things and change them. They're based on standard things like Modbus registers, and there's a protocol and system to do that. And I can share a lot more detail on that. if required. This is something that I discussed in another one of my webinars, which was Emax to communications. But if you need more detail, I'm happy to help, happy to support.
Thank you. Another question from a distributor. Is the ATS embedded functionality able to be used in NetGen application?
Next.
Net, N-E-T and /GEN applications.
I'll probably have to find that out, what that exact application is. I'm not quite sure.
Okay.
Maybe I'm not.
Neelan, if you'd like to elaborate on that question, please continue asking a question and I'll come back to you. Let me just go to the next one. Is there an IEC standard governing the electrical interlock? And if so, has the Emax 2, has it passed the test?
If we are talking about electrical interlock during an ATS setup, then obviously this is only with open transition. Now, there were certain tests of logics done by factory based on our feeder factories based on certain applications. Now, what that exact standard is, I can probably I'll probably have to check. I don't remember the numbers, but there's definitely a certain authority, a global authority, which is, let's say, instructed or given us guidance on what tests need to be done in a certain setup. So I can find more detail and provide that particular testing procedure to you based on which standard. I'll have to check that.
Just going back to that question about is the ATS embedded functionality able to be used in network and generator applications?
All right. Yes, that is possible. There are certain setup limitations as we have. So we don't have, we mainly look at the embedded ATS in a main gen setup. We don't have in open transition. We have a main bus tie gen in the open transition setup. The closed transition, we don't have certain setups like the main bus tie gen. So there are certain functionalities which are not yet ready, but most of them in a network generator, there's no issue. We can always look at that functionality, which is available now.
Thank you for answering that. One from overseas. What are the possibilities of if someone wants to retrofit solution, the retrofit solution for an Emax 2?
Emax 2 is relatively quite a new product, so we don't have. I mean, if we have to retrofit an Emax 2 to another Emax 2, that's quite straightforward because the footprint remains the same. But if the question is related to let's say older legacy breaker like the new Emax, we have a direct replacement kit which allows us to have the Emax 2 installed within the fixed part or cradle of a new Emax breaker. That's something we call the direct replacement kit. Quite easy to put together in terms of setup. So the existing setup, bus bar connections, cables, or whatever we have, control wiring remains as they are. There's certain adjustments we need to do on the terminals of the Emax 2, and what we get is ready to rack in moving part, which is the Emax 2 with certain kits and parts which are put together now, and that becomes a plug and play solution. So we remove the old breaker, new Emax, and put in the new Emax 2 within the same fixed installation. And these are certified kits, so there's certain levels of testing done in terms of looking at whether it's selectivity or coordination, or even if it's looking at temperature rise and a few other things, there's certain tests done at factory. So it's a factory, it's an ABB product. It's not something we do locally.
Very good. Another question from a colleague. Can you install the new trip unit on the current Emax 2 breakers?
There is, so the trip unit becomes a part of the main cradle. So yes, that is possible because the mechanics of the breaker doesn't change. But it would just not be as easy as replacing the trip unit. We would also have to look at the chassis of the, the cradle of the breaker, which is made of plastic or a certain kind of industrial plastics and a few other parts. So there are spare parts required to replace that, but wouldn't be as simple as 2 screws out and the new trip unit in. The whole electronics needs to be changed. And given that we have higher level of accuracy, we would also have to look at changing the Rogowski coils or the current sensors within the breaker. So it's probably not recommended because that would be quite cumbersome, and it's not something which can be done quite quickly even, because a certain breaker has a certain name and a serial number that needs to be tracked back to the trip unit setup, and everything needs to be designed from factory in that setup, and then we can do the transfer. It's probably a lot more easier to look at a new breaker instead if we are looking at the new logics. However, other than the accuracy side of things, the Emax 2 with the classic gray or the previous version of trip unit still has all the functionality that I discussed today. Only thing we're missing is accuracy, and we're missing the Bluetooth technology.
Thank you. I have a similar question from overseas to that one. Can we replace these trip units with the trip units of Formula Air ACB?
Formula, as far as I know, is a molar case circuit breaker. So the answer is no, cannot be done. That's not possible. The breaker itself, the Emax 2, is set up in a certain way that anything related to Emax 2 needs to be replacing. So any spare part within the Emax 2 needs to be a Emax 2 spare part. Can't be from a different range. So.
Okay. Now we have more people that have left. I'll just ask one last question because I am conscious of time. And again, I will remind everybody that Dippy will take the unanswered questions and respond to you offline. Let me just find the last lucky question. 1 second, because I've got people commenting. How does the derating factor is being considered while making the breaker so compact?
Yes, most definitely. So we always declare, from ABB point of view, we always declare our temperature deratings. That changes. So there are two levels to this. So one is the temperature derating of the breaker itself based on power losses and the size of the breaker as it is. How the E 1.2 is designed is trying to have the right mix between size and performance, and that's where Emax 1.2 excels. Now, depending on the kind of setup. So if you're looking at a really narrow panel but high levels of performance, that probably may not work based on temperature rise on the whole cubicle, which is followed through by 61439, or the temperature rise, I don't remember the code, it's 60822 or something. So that depends totally on our calculation, and the declaration that ABB provides is on the derating of the product, and then we have certain tools to calculate also temperature rise within the switchboard tier.
Thank you, Dippy. I'm afraid that we'll have to conclude the question time and the webinar. I'd just like to remind everyone if they could just stay online for a very short survey, and we'd like to get your feedback. And thank you very much for joining us this afternoon, and we hope to see you on future webinars. Thank you, and have a good afternoon.
Thank you all. Thank you, Isabel. Have a good day, everyone.